Hi everybody, I would like to go through question 7 again because some of you mentioned that you need me to go through the thinking process of how to structure the answer, okay? Please take note here, I am emphasizing on the structure of my answer because in this case there are so many things to write. So how would you structure your answer such that you get all the key points? Alright, so firstly, let's take a look at the question. They mentioned that you need to describe the various forces responsible for keeping the particles together in elements and compounds and their effects on the physical properties, making use of the data below. Okay, so firstly, if you take a look at physical properties, over here if you look at the table, we are simply just talking about melting point as the physical property. So when you think of melting point again, the keyword structure, bonding, energy should be in your answer. So based on this, right, describe the various forces that keep the particle together. In this case, that means we are referring to our bonding, okay, because bonding will keep the particles together. So based on this, very simple, take a look at all the different substances. You have so many substances over here. You need to be very systematic. So straight away, you will just decide what is your structure, what is your bonding, and from there we will be able to conclude our energy. So for neon, okay, the structure definitely is SMS. And what about the bonding? It is definitely VDW is our bonding. Okay, for argon, moving on, argon is also SMS for our structure and bonding is also VDW. Okay, what about for water? Also simple molecular structure, and in this case, it must be hydrogen bonding, that is our bonding between the particles. Moving on from here, okay, I'll erase all this first. Okay, moving on from here, sodium fluoride structure definitely is giant ionic structure, and the bonding must be the strong electrostatic forces of attraction. Okay, you write on your own. Diamond, of course, is giant covalent structure, and it is strong covalent bonds between atoms. So based on this, straight away you will be able to link to the last point, which is energy. So very simple to structure the answer. You notice that diamond and sodium fluoride is in its own league. One is giant ionic structure. Definitely you have a very high melting point. So straight away, in its own league, right, very easy to talk about it. Straight away just mention giant ionic structure exists strong electrostatic forces of attraction between the oppositely charged ions. How to link to melting point? Of course, again, you need to have large amount of energy needed to break the strong ionic bonds, and hence it has a high melting point. Okay, please take note, over here, this statement here, although we say strong ionic bonds, but you notice our key marking point here, the half mark, is for strong electrostatic forces of attraction between the oppositely charged ions. So that means if at this point in time you put strong ionic bond here, you actually won't get your full credit. You should actually be explicit to write about the strong electrostatic forces of attraction. Okay, so moving on from here, we have already talked about sodium fluoride. So now let's take a look at another substance which is on its own league. So in this case, we have diamond, giant covalent structure. So moving on from here, diamond on its own, we can say that it has a giant covalent structure that exists strong covalent bonds between atoms. Take note to add this point in a three-dimensional tetrahedral network. Why three-dimensional tetrahedral network? Remember this, you draw in your secondary school. This one you continue to draw, it will be a 3D tetrahedral because all these are 109.5. Okay, tetrahedral. And again, you have large amount of energy needed to break the strong covalent bonds, thus it has a high melting point. So moving on from here, I have already put in my sodium fluoride and diamond. other things that is not talked about is of course my neon, which has SMS, argon, which has SMS, and water, which has SMS. So I can actually group all this together to talk about them. And furthermore, you notice that water is very special because it's hydrogen bonding. So straight away, you group them together. Okay, they have simple molecular structures. However, you notice water have hydrogen bonds between the molecules, more energy needed to overcome the strong hydrogen bonds, thus it has a higher melting point, which is true because 0 versus all the negative numbers. And finally, if you take a look at neon and argon, both of them have VDW and VDW. So what are the two factors that you need to talk about here? Okay, of course, number one, you need to think of the electron cloud size. And number two, you need to think about the shape of the molecule. But of course, in this case, you know that your neon and your argon, both of them are your monoatomic elements. So in this case, actually both of them have the same shape. So shape is out. So it must be the electron cloud size, which you can immediately see from the MR is 20 and the MR is 40. Okay, so in this case, very simple. Moving on from here, you need to zoom in into neon and argon. There exists weak van der Waals forces of, this part should be attraction, between our atoms. Please take note, this is atoms. If you put a molecule here, it will be wrong because argon and neon, they are our monoatomic elements. So from then on, please continue to mention argon has a larger electron cloud, okay, than neon, and hence is more easily polarized, and thus the strength of VDW are stronger between argon atoms. Please indicate that you are referring to between the argon atoms. Okay, I always like to emphasize the importance of writing between. And then from then on, you have more energy needed to overcome the intermolecular forces, and argon has a higher melting point. Okay, so as a summary for this question, let's go back to the table again. As a summary, if you notice how I structured my answer, I firstly target the substance which have a structure that's very easy to explain. For example, ionic structure. Then I will move on to another substance which has a structure that is very easy to explain, giant covalent structure. Then I will move into the group SMS. Okay, since all of them are SMS, we will need to divide them into either VDW or hydrogen bonding. And for each of these van der Waals or hydrogen bonding, I can talk about the shape of the molecule, okay, or my size of electron cloud to further explain which will have stronger intermolecular force of attraction. So that is how I structured my answer.